Let me. I guess let's start with the first slide. We got to talk Python generators, from yielding resources to weighting concurrency, and we're going to learn how to use generators to do multiple things at the same time, or to save on resources on resource-constrained devices, and all kinds of fun things. So,
possible to make the font a little bit bigger.
Make the font bigger.
Apple or Control Plus.
Is that better?
Yeah.
Yes.
Yes, that's good.
Perfect.
Much better.
So this entire slide deck thing is written in PyScript. I don't know if you guys have seen Jeff Glass's talk on PyScript, and it's basically Python in the browser, in WebAssembly, and so we have a whole Python core running in here, and this whole thing is running in the browser, so that's super cool. But anyways, each one of these slides here, we kind of have a little bit of markdown here so we can say what it's about. And then you'll see that there is some code here. And when the page is loaded, all the code that you see here is run on page load. And so you can see here, we've got, these things are going to be a little bit squished. Each one of these, we have a terminal. So you can type things in, and you can see that we have this gen object, which is this generator of this generator function. So basically, in the simplest form, you can think about, or I guess this is just my introduction. We'll get to the next one. So again, my name is Andrew Wingate. I run a robotics company named Evezer, and this talk is about generators. So here you can see that we have just gone through a generator, and we're yielding values as we go. So again, generators at their simplest form are iterators. You can use them and think about them just as iterators, and every time that you run next on them, they will yield a new value. So you can kind of think of yield like a return statement, except when we do this kind of stuff. So again, let's get a value from our generator, and you can see that we have gotten our first value, but then we can also, in the same time here, do different things. So we can start our generator, but we don't necessarily have to finish it until we want the next value. So with generators, you go through, and as soon as you get to the end, you're going to get a exception, and it's a stop iteration. So from that point, if you keep asking next, you'll keep getting this same exception, and then obviously you can just start a new one and go through to the end, and that's pretty much the simplest way to think about generators. So here we'll continue on, and you can see that you can use generators to save time and memory. So in here, if you were to have this as a list comprehension, when this is calculated, you'd actually have to have a list with 1 trillion elements in it. And my computer would run out of memory, and we wouldn't want to wait for this. Our talk would be over before this is done. I know you all like Python, but it's kind of slow sometimes. So again, we can look at our generator object here, and you can see that this is a generator expression. If you guys are more familiar with this, you'll kind of notice that maybe this isn't looking exactly like Python. I happen to be running MicroPython, PyScript, the MicroPython version. So some of the words that it says what it is isn't exactly the same as you'd see in Python 3, but generally the way that your usage is going to be, it's going to look similar as it can. So again, we effectively have a list of 1 trillion elements, and we can iterate through this thing and just lazily execute as we need more values. You can also stick generators in a for loop. So you can go, and here I'm just having it kind of do a number of bottles of beer on the wall. So we'll just hit sing here, and you can see that here we're going to go, for beer in this function, this generator function, take down beers, we'll go ahead and just post to our terminal here. And you can see that we have gone all the way through this, but we never actually had to handle the stop iteration. But you'll see if we do this just normally here, we'll do 3. Spell that right. Maybe I should have picked 1. And there we got our stop iteration. So you can see here that like you can use a for loop to go through any kind of generator, and that's another way to kind of go through them. Because again, generators themselves don't actually do anything. You actually have to have something else physically run through them and call next on them or whatever it is you want to do. Generators won't really do anything themselves. They do require a little bit of hand-holding. So again, we've just gone through with a for loop, and in here we'll introduce yield from, and you can kind of think of yield from. This one was a little bit interesting when I first started seeing it, but yield from, you can kind of think of it like an implicit for loop on another generator. So as we go through here, we have a little generator comprehension. We have a list. We have another dictionary there, and then a string at the end. And you can see that as we start going through these things, we are just iterating through each one in a time, and until we hit our stop iteration. So this yield from is pretty powerful when you're wanting to have a bunch of tasks all together, and you can kind of use that to as syntactic sugar to just help keep things looking pretty, like we like to do in Python. Continuing on, we can kind of start to build some kind of pipelines. And again, this kind of becomes a little bit more important when you're using something like resource-constrained devices, and you can't really create an entire list or write to a file or execute the entire thing before you want to actually use any of the values that you would be pulling out of here. So again, this is the bottles of beer on the wall, and we can now, kind of nest our functions in here. We have the takedown again, but then in here, we're also going to sing more of the verses and actually like have the entire song. So let's go ahead and run this one, and you can see here, we have sung through the entire song. 5, 4, 3, 2, 1, 0 bottles. Maybe it's time to find another bar. And also, I guess this is a good time to mention, I don't know if it was mentioned by Phil, but all of us usually will meet at a bar afterwards. Do we know which one we're going to?
Blue Aqua Hotel Bar.
Okay, come find us at Blue Aqua if we want to continue these conversations. So we have looked at generators just as a iterable. So, we're going through and it's just like, let's have some values back, let's have some values back, and that's pretty simple, but you can also send something into generators. And so if you kind of look here, let's go ahead and just start this guy off. So we have created this simple generator here, and the first thing, I don't know if we can fit all this on the screen at the same time. Okay, I think we got this. So with generators, again, they always need a little bit of hand-holding. So you can see that we have this generator object gen here, and before you can do anything, you always need to start a generator. And to start it, you'll always call next. Even if there isn't anything to do, you're always going to have to kind of baby it along and like get it started. So you can see here that we have called next. You can see that we've run past this post, but now we are at this yield right here. And this is where generators start to be really interesting, and you can do very interesting things here because we can now go gen and send So we have our generator, and we will call the send method on it. And let's just go hello ChiPy.
ChiPy?
No hippies? So when we send this value in here, it is actually going to end up going in, and value now is going to be what we send in. And we've just now gotten to this line, value equals value, in this case, hello ChiPy. And we have now gotten to this next yield statement. Let's go ahead and just send in this 5. Oops. Oh yeah, that is actually correct. That's what's supposed to happen. So you can see here that we gave in the value 5. We now have second value equals 5. There are no more yield statements. We have completed this, and now we raise our stop iteration.
Ask a quick question.
Yes, of course.
What would have happened if you would have called next on that instead of sending the value?
Great question.
That is a great question. Why don't we just do this?
Repeat the question for the recording.
What's up?
Repeat the question for the recording.
Oh, yes. So the question was, what happens if you, instead of sending send, if you just called next on this? So let's go ahead and look at that. So we have created this simple generator again. We will call next on it to get it going. We've gotten past our first yield. It is going to now want a value. So now instead of hitting send, we're going to go next on this generator. And you'll see here that it actually did send something. It just sent none. And so it's not going to break anything unless your program is expecting something. And typically in these, I think that you're probably going to be expecting some kind of value to be passed in there. So
Why does it send none?
I'm sorry?
Why does it send none?
That is a question that is above my pay grade.
I was wondering, if you don't mind the live
Of course.
coding, feel free to pun on this. Could we try doing a for in gen instead of nexting on it?
Ah,
Yeah, I think that's useful to show, because if I remember right, I think when you iterate through it using the for syntax, you get the sugar of, it catches the
Stop iterations.
error, the exception. And then just like print G or something, or we'll see if it works. But if I remember right, I think that's supposed to be the
yeah,
behavior.
I did that right. I can Python. Let's open up the terminal here.
And we can skip it if it's like,
I'm sorry?
we can skip it if it becomes a distraction.
Oh, no, it's just something, these aren't real REPL prompts. And so you can see that I passed in a non-breaking space character and Python's like, I'm out.
Yeah.
So we should still have our generator object here. We do. And now we are going to, actually, we never needed it, right? Because we are creating a new one. I think this has something more to do with my not quite REPL prompt REPL. One of the greatest things about Python is it's written in Python. So you can do dumb things, but sometimes you end up with dumb results.
Yeah, thanks for trying to.
All right, so we have this little more not so simple one here. So let's go ahead and spin that one up. So can we guess what's going to happen when we next this guy? Are we going to get anything back?
None.
No. We get a 5 because we have this 5 right in front of the yield here. So if it's past the yield, it's going to yield that when you next on it. So this not so simple example, we have now reached this yield. It has yielded this 5. That's the first next. Now we want to send something in. So we can send 10. And then you can see that we have gotten our 10 back. So again, we start this guy. It yields 5 because that's on the right side. And then we can send a value in. and we're just yielding that right back to us, in which case you'll get whatever it is back. I know that this syntax is not the most friendly thing in the world, but that's what it is. So let's continue on. And now we'll try to have some concurrency. So we're going to have multiple generators going here. Let's go ahead and close this terminal. I have just created this object here called Gene, and Gene can basically hold on to a bunch of generator objects. So we'll just have like a key value store here with a dictionary of our gens, the name of it, and we can just hold on to those, and it will also hold on to its own generator, which is generating through the generators. So we have a generator generating through generators. So I kept this here, so we'll go gene.startParty, and this will kind of get to things and get things going, and you'll kind of see where some of this comes in later as we kind of pull open the sheets on some of this stuff. So essentially here, we can say next to Gene, and it'll get back to us and say we currently have no generators, and you can see that we have no generators here, and so there's nothing to give us. So let's go ahead and create one. And if you're wondering why these buttons are out of order, it's because when I created these, they are all dictionaries, and you guys don't know how good you have it now that dictionaries in Python 3 they preserve order. But that wasn't always the case, and that is not the case if you're using MicroPython. The order of your dictionaries will be not random, but ordered on the hash value. Were you going to say something?
Arbitrary.
No order dict in MicroPython?
There is, but for the sake of this, I was just keeping things simple, which makes the buttons not simple. There is ordered dict, yes, but I figured I would leave that one just so that I could pass along that little nugget of, you don't know how good you young kids have it nowadays. Yeah. So now I've asked Gene to create this generator called alpha, and you can see that it has one. And now when we ask for a value, it's going to say, oh yeah, I have this generator called alpha, and we are now yielding the first value. We can go ahead, another one, we're yielding on, and now let's create another generator. So we can do beta, and as we go here, now we have beta, now we have alpha. Again, this is MicroPython. We have a dictionary object. It is not preserving any kind of order, so we don't get any kind of order as we're kind of iterating back through these things. Let's go ahead and just do delta and gamma. We'll start going through here, and you can see now that we have a bunch of different generators, all at different values, and they're kind of all doing their thing. We can do other things in the meantime. We'll just post some more, hi. We're going through these, but we don't necessarily have to finish. We can just throw it on a shelf, do some compute over here, come back, continue on. We will just keep continuing on here, and you can see that our object here, Gene, has gracefully handled our exception here of when we got to the end of our generator, and gracefully just deleted it from the list, and we can continue on. So can anyone guess what this Gene object is very close to that we use in Python? No one uses async IO? Okay. We got people who love threads and callbacks.
Subprocess.
Or processes, yes.
Subprocess.
Well, anyways, yeah, this should should look familiar for anybody who is used to async IO. We have this create gen function up in Gene. This is synonymous with create task. Start party. We get our event loop, run forever. And this kind of do gens thing is handled under the hood with async IO and our iterator. Yes.
Is this kind of how it's implemented in pure Python, kind of the demonstration you're giving us?
Yeah. So let's go ahead. I'm going to hide that little picture first. So you can see here that I have an async function. So we have async IO here. We've created an async function here called delayed posts. And you'll see here that if we, yes.
That's from the end.
Yep. That when we asked delayed post what it is, we actually get back a generator object. So to continue on with that one, for any kind of generator function, creating an object that you want to await on, it will have to have a dunder method of a next and another one that I cannot remember the name of. But those are the two dunder methods that async IO is going to want any kind of object to have when it is kind of iterating through these things, and you have some kind of function that is awaitable.
I think it's iter.
That is the one. That is correct. Yes. Yeah, and I believe that iter basically is like the generator object itself. So up in our up here, we actually create gen, and we actually are yielding a generator back. That would be the iter function is create me an iterator of self and pass it back so that the event loop can pick it up and start working on it. So again here, you can see here that as we're doing this, we are just waiting for a period of time as we're doing these. And again, we can just kind of load it up here, and now things can be handled concurrently. Again.
So I come from the JavaScript world where an async function can be written in non-async JavaScript. Is there an equivalent way to do that in Python?
Okay, yes, actually, sorry, that was the picture that I
That was the
said,
Gene class?
We'll get back to this one.
Okay.
So, yeah, that's a wonderful question. Okay, so we have this, and in JavaScript, it is a little bit different, and you can have they aren't separated as nicely as Python wants to have them. But you do end up in a similar kind of situation where it's okay, yes, I have some function, I have a function, more functions, and then all of a sudden you bring in this async guy, and everyone has to kind of change to go with the paradigm here that we have these awaitable functions, and as soon as you start adding some of these in, then it kind of I'm not going to say pollutes your code base, but your code base needs to now be geared towards async IO or any of these kind of async functions.
Borg?
I'm sorry?
Or like the Borg?
Could be. I don't know. I found this on the internet. Yeah, so that's async IO. And so I think that I'm kind of running out of time here. So I have another one of these robots here, and it has a suction cup and can move around and play a game of checkers. So I figured I would just kind of show you a little bit of what that program looked like. And I'm actually curious of how you guys feel about some of this. So anyways, the board is kind of fashioned like this in the code. We have columns A, B, C, and D, and we have the rows here, 1 through 8, If anybody is offended that I didn't start with 0, you should be using iterators anyways and just go away. So let's take a look at our code here. Again, it's for a machine just like this one. So we have a couple constants up at the top about how we're going to move and where we're going to move some things. We have also created our board. In these, it's actually the joint angle is going to be each one of the squares on the checkerboard. And as we move on here, let's kind of start from the bottom here. These are the moves. So like I showed you the board, you can move a piece from D3 to C4, or from C6, we're going to remove it from the board. And this is some famous game or something like that. So again, more stuff I found on the internet. I guess I could have asked ChatGPT to make me a game, right?
Why are there only 4 columns instead of 8?
Well, you only play on the black,
Okay.
right? So like you could, but then my stupid human brain, as I'm trying to like figure out which pieces should move to there, didn't like having to like do some extra math of whether I'm on the even or odds. So computers are fast. Python is wonderful. Let's just let Python take care of it. And you can see right here, this is where we're going to actually go in here and figure out like which list element we're going to look for to actually pass back to tell the robot to move there. So let's go ahead and just like start this game here. And as we call next on this, we are going to start getting some of these values back. And I guess here is where I'd kind of be interested to see how you guys feel about this, like on the inside. So when classically on machines, they run this code called G code. And so for a code like this first one, command move.linear, that would be G1, because all the functions are just serialized. And then you pass in some quargs. So in this case, you'd have x15, y some other value, and then feed at some. So basically this is move in a straight line to some point, and the from is implicit based on where the machine is at the moment. But I'm just curious of like, what do you guys, when you guys look at this, is this something like, how does it make you feel on the inside?
I'm offended you didn't use chess notation. It's not that big.
I did look at it and I was like, I just didn't want to build a parser. So
It's okay.
I should have, I don't quite
Should've.
understand it.
I think you should have made an enum with all the offsets and the commands.
All the offsets as a command.
Like x122.0 would make an enum instead with the offset. But the numbers,
Here?
yeah.
Well, those values are just like passed in. What do you mean in enum?
Like a table instead of like hard coding 122.
It's not. So this is a generator. Again, like we are running this program here. So I guess we'll kind of walk through this here real quick. We have this play game and we're passing in our game object. Our game object is this list of strings here. So these are the moves.
Oh.
Our first one is move from D3 to C4. So effectively it is moving to D3, which is at this 122 14 number. So we've just said, I want you to move. We have a piece over here, move above it. And then the next one is move down. And then this next one, we're just saying evaluate this function. We have this object called suck, which is the suction cup. We're like in hardware land now, and turns it on. Waits for a little bit so the motor can do its thing and we can actually get a vacuum going, move back up, move to the next location, which in this case would be seafood. Like we should be able to, I believe. That should work, right? Yeah. So, position C4, what gets returned back to us is this XY location.
That's just the XY notation of the sucker, right?
Yeah, this is where the black square is on the checkerboard.
Is it like the center of the square, or is it like a corner of the square?
Yeah, it's the center of the square. So I have a video that'll be posted soon about how I did this, but basically there's encoders on the side here, and I kind of just like dragged it around, and I just started hitting a button, and it just created this table.
Oh, so you didn't write the G code? Did you?
Well, again, like the G code is coming from, like everything that you see here is just coming from this Python code.
Yeah.
The Python code creates a G code and then it's interpreted by machine.
So so what I'm asking you guys is like, G code is gross and nobody should be writing it. And it should just go away.
What are you asking us?
Just how it makes you feel on the inside. Is this ugly? Is there some other way that you think that like you would want to tell a machine to do something?
Well, I would just say this reminds me of like Turtle or Logo. The old, turn left, turn right, and up and down kind of thing. And I'm just thinking in terms of that, the only thing that's confusing here is simply the fact that you have to specify things by like, XY position or something nice about Logo, or I guess the Turtle was like, it seemed more.
So these are absolute positions, and you can do relative programming as well.
Yeah.
So like, I have this kind of working, I don't really like relative programming.
Yeah.
Because like, now you have to think about where it was.
Right.
And again, when you're writing something like Python, it can go ahead and just like dig through a whole list and kind of figure stuff out and just do the math for you. The fact that you moved it 5 is arbitrary, and whether or not you want to.
Does it move to origin after each move, or can it go from whatever square to whatever square? Does it have to move back?
No, it can go from whatever square to whatever other square. And I guess one of the other things that's kind of going to be missed by this is the fact that like when you're telling a machine to do something, let's say that you have something you're going to move from this point to this point to this point, and they're all in a line. You don't actually want to move and then stop and then move and then stop again. You have to fill up a buffer of the moves, and it's like, oh, I'm at this speed when I hit this point, and I'm just going to crash right through it and continue on to the next one.
Yeah.
So there's kind of a dance that has to happen there where you like have buffers and things have to happen. You have to think about the future before you actually pass it to the robot.
Yeah, in a previous life, I worked in supply chain, and I worked with manufacturers that were using, like 3-axis machines and writing machine code, writing G code. They have like CAM software that will optimize those paths. So, like you're saying, if I want to mill, the face of something, it'll kind of say like these are the speeds at each end you should be at, and how it moves. So it's like a program that writes it out for you.
Yeah, absolutely. And kind of what's sort of implied with some of this, and I'm asking how you feel about this. Nobody really should be writing very much G code at all.
No, it's
I talked to high school. I'm a journeyman machinist as well.
Oh, okay.
I was running CNC machines. I went to college, and they taught me G code, and I'm like,
yeah.
I was already running the giant machining centers, and I'm like, nobody should be writing this ever.
Well, it's like should I learn assembly? No, you shouldn't.
Exactly.
Higher level program.
You might be delighted to know that I've talked to college students lately, and they are still teaching it. And in relative mode, and like with offsets and all this like idiotic stuff, it's like human brains aren't meant to write assembly or G code or any of these things. Let's bring it up to a higher level.
Thanks.
Yes.
They actually looking for maybe like doing the moves all in like a virtual board, and then the thing could just decide what to do based on where the current position is and where the destination position is. You just like the virtual board says move from square A to B, but that would translate to a decode as a separate interface. Do those moves maybe?
Yeah, there's kind of a lot that can happen under the hood, especially with a robot like this. So the question was, when you're asking a machine to move from one place to another, it's not necessarily one command. Is that kind of what you're getting at? And especially with a machine like this, it's like move.linear. We want to move in a straight line, but a robot arm has no concept of straight lines. So a straight line to us actually is an arc when you're talking about it for a robot.
All right, I'll take the mic. So you were asking about how we feel about it.
Yeah.
And I hear you defending how it works, which is, I totally hear that. But ultimately, like if I wouldn't buy this because it's too much detail up front. You know, this data of the G code, is that what you said, G code?
Well, I'm also hunting for a word for it because like
Yeah.
there are no kind of like high level. I haven't found anything like it.
Okay, that's fine. This
so-
is called G code. My feeling about it is it'd be cool to get different levels of debugging information out of this. Like what you're talking about with the virtual board would be more accessible to me working on this thing. And like, oh, this is moving from whatever. It's abstract. It's not direct code for the robot. I want to go deeper and see, okay, actually, what is the XY coordinate? What is the G code on it? I'd like to be able to access that as needed, but if it's only showing me code like that, then my feeling is overwhelm and confusion.
Okay.
Is that what you're asking for?
No, yeah, that's fair. That's fair.
I actually, to inform my own feelings, I looked up G code and I agree with you that this is better. You should just call it like macro Python. So you used it for macro thingies. It's very assembly-like, so I
That's a
see what you
very
mean.
interesting concept there. Okay. Very cool. Okay, I guess we can move on. So again, you know, what this ends up getting compiled down to currently for the machine, we have a whole program up here. It's written in Python, but then once it becomes compiled, this is kind of like looking at machine code. And actually, I think that this is our last slide. So thank you. If you want to find out more, you can go ahead and look at this link, and I'll be posting more updates and everything on what I'm doing. Yep.
Question. So you showed the example, so, you know, obviously you do the yield, there's, like the for loop, the while loop, you can iterate through it.
No, it's not
You can automate steps, automate the thing, next. Is there something similar for that for the send? So like you wanted to send a bunch of stuff? Like you showed how you'll yield and wait and then take input and send. Is there a way to pass that send value in? So you can have like the two gears like cranking at the same time. One's yielding and one's sending.
Well, I mean, if I'm reading what you're saying correctly, you know, you have to get these values from somewhere. So you're probably just going to be kind of building something yourself, where you're iterating through some kind of iterable and sending these values to some other generator over here, and you're just kind of having some function that's sort of just doing this thing.
Generator.
And then I guess the last thing, I was just going to start up the robot, and hope you guys are curious of this whole slide deck here. Here's a programming environment that I'm creating to help make these, so you can drag hardware objects on here, like the suction cup or the pan or servos or any of these things, and kind of put them together. I know that I've kind of abused it here a little bit, but so it's Python on the back end. You can run it on the ESP32, which is running MicroPython, or just run it right in the browser. So I think that it's kind of neat, but let's,
Well, we started.
sorry, the
I try to call it a four-time phone, or like tool.
Zoom thing keeps getting in my way.
They're up by green.
Yeah,
I want to catch.
So this is the
Oh, there you go. It says vulture.
website that is being served by the
How is that?
robot over here. Let's go ahead. I'm going to,
I don't know, find out.
I think I did this already. We're just going to draw another ChiPy sign.
What did you do? Here we're doing 12.
So thank you very much.